October 20th, 2025. AWS US East 1, their biggest region, had an absolute meltdown.
It was pretty significant.
And this was, well, far more than just your typical cloud service hiccup, wasn't it? Our sources, they're arguing this specific failure really exposed something they're calling the AI infrastructure monoculture crisis.
Mm-hmm.
So the mission today really is to understand why a glitch in Virginia had, the entire AI world basically gasping for air.
Right.
It showed a systemic dependency that's, well, surprisingly fragile.
It absolutely was a global choke point.
Mm-hmm.
I mean, while the failure centered in US East 1, it really did impact core services that people use worldwide.
And the initial reports mentioned DynamoDB.
Yeah, the headline was DynamoDB API failure, some DNS resolution issues too. But if you dig a bit deeper, the actual root cause, it seems, was a failure in an underlying internal subsystem.
Internal.
Yeah, something that monitors network load balancers. And that error, it sort of cascaded and essentially just pulled the rug out from under crucial data services.
Globally. Wow. And the casualties were, well, they were immediate. We saw some really high-profile outages.
Perplexity AI, for instance.
Right. Perplexity AI's CEO explicitly confirmed their disruption stemmed right from that AWS issue.
Yeah.
And it's a huge reminder, isn't it, that even platforms like, say, Coinbase or Robinhood, platforms that often talk about decentralization, they still rely so heavily on that centralized cloud infrastructure, at least for their front-end access,
Absolutely. And what's fascinating here, I think, is how the outage created this specific double whammy disaster just for AI workloads.
Okay, break that down. Double whammy.
So the first hit was inference disruption. You have loads of real-time AI services using R now.
Retrieval augmented generation, where the model pulls in outside info.
Exactly. It needs to grab external knowledge in real time, like chat history or maybe specific documents. Because DynamoDB failed, the LLMs just couldn't retrieve that critical context.
So even if the GPU, the brain, was running fine.
Right. Even if the compute was humming along, the application was basically starved of info. It became, well, useless.
Like having a perfectly functional brain, but zero short-term memory access. Ouch.
Precisely. And the second major hit was training interruption. Think about these massive synchronous LLM training tasks, multi-billion parameter models.
Right. There's huge, expensive training runs.
Yeah. The EC2 internal network problems caused those big synchronized clusters to just fail entirely. When one node in a massive, tightly coupled job stalls out,
the whole thing stops.
The whole process halts. And that means just a tremendous waste of incredibly expensive GPU hours. And time, of course.
Okay, but that brings us back to the core question. Why are all these, cutting-edge companies even relying on the same failure domain in the first place?
Well, that's the monoculture crisis you mentioned.
Right. We've all talked about algorithmic monoculture, everyone using similar models. But this is the infrastructure monoculture.
It's the sheer concentration. The vast majority of global AI workloads are sitting on AWS, Azure, and GCP, the big three.
So what does this all mean? Why should you, listening, care?
Well, this concentration, it's driven purely by economics. It's the GPU supercycle.
Ah, the scramble for NVIDIA chips.
Exactly. Only these hyperscalers really have the capital, the buying power to secure the limited supply of H100s, B200s, whatever the latest hot chip is.
So if you want that peak performance to compete,
you're kind of forced into vendor lock-in with the providers who actually manage to buy the hardware. There aren't many choices for that scale.
But isn't setting up, say, a multi-cloud deployment often seen as prohibitively complex, especially for anyone but the really big players?
It absolutely is complex.
Right.
Which is why this event, this outage, is sort of shifted the conversation. Multi-cloud went from being maybe an optimization goal, something for efficiency,
to basically mandatory.
to mandatory business continuity. It's a requirement now. And yes, it introduces a complexity, especially around data. Moving petabytes isn't trivial.
You need specialized tools for that, right?
Yeah, you need systems like JuiceFS, for example. It's essentially a distributed file system designed to help maintain data consistency and coherency across different cloud platforms, handling that massive scale.
So this crisis has really kicked the industry into high gear, forcing them to engineer specific solutions. Here's where it gets really interesting.
Yeah, we're seeing alternatives emerge.
Like specialized clouds, we're seeing companies like CoreWeave mention more.
Right, CoreWeave is a good example. They built their infrastructure basically from the ground up, specifically aiming for bare metal GPU performance. It's designed just for AI workloads.
Like building a racing engine instead of a general purpose SUV?
Kind of, yeah. And Another angle is using AI itself to solve these problems, AI ops.
Using AI to manage the infrastructure.
Exactly. Using machine learning to analyze just the vast streams of logs and metrics, trying to predict when internal components like that load balancer subsystem.
When they're about to fail.
Yeah, catching it before it causes that cascading DNS disaster. Proactive, not reactive.
But maybe the most critical fix, or at least the most immediate one, is at the application level itself. Graceful degradation.
Oh, absolutely. This is key. Instead of the application just throwing up its hands and showing an error when, say, DynamoDB is inaccessible.
It should do something useful.
It should be designed to automatically fall back. Maybe it uses only cached data it already has, or relies solely on its pre-trained knowledge without the real-time RA context.
So you get maybe a slightly less perfect answer?
You get a potentially suboptimal answer, yes, but you avoid a complete service outage. The user still gets something. Basic continuity. So I think the core lesson here is really clear. AI's explosive growth has definitively outpaced the resilience of its underlying infrastructure.
The foundations are lagging behind the skyscraper.
Pretty much. Investing in diversified architecture, multi-cloud, and resilient application design like graceful degradation. It's just not optional anymore. It's a non-negotiable business cost.
Directly linked to preventing those really costly outcomes like RA starvation or just burning through GPU training budgets for nothing.
Exactly right.
Okay, that leaves us with a final provocative thought for you, the listener. We know there are real performance challenges with decentralized compute networks, things like the straggler problem, where one slow node can really drag down a big synchronized training cluster.
Yeah, that's a known issue.
So, given that relentless push for peak performance for the absolute cutting-edge models, will that need for speed always mean we remain at least partially locked into these centralized hyperscalers, even though we now fully understand the huge monoculture risk involved?